Hello guys, Guilherme here and welcome to GeeklyEDU Mathematics. Today we're going to solve some integrals using the change of variables or substitution method. So it's very important that you watch our previous videos on the same topic before watching this one. Our first problem, we want to calculate the indefinite integral of x cosine of x squared dx. Okay, so let's try to simplify this integral here. Let's call x squared u, so x equals the square root of u. Now from this equation here, if we derivate x squared dx and u du, we have that 2x dx equals du. So dx is du over 2x, and x we know is the square root of u. So dx is du over 2 times the square root of u. Now we go back to the integral, okay, and do the substitutions. So x is the square root of u, cosine of x squared is the cosine of u, and dx is du over 2 times the square root of u. Looks more complicated, right? But we see we have square root of u over here and square root of u down here. So we end up that this is half of the integral of cosine of u du, and this is a much simpler integral. So the integral of cosine of u is sine of u, and we have half over here that multiplies. And never forget the constant, okay? That's an indefinite integral, so we have a constant here. Now we need to go back to our original integral. So the integral of x cosine of x squared dx is equal to the half of sine of u plus a constant plus k. And u, we know that u is equals to x squared. So this integral here will be equal to half of sine of x squared plus k. For problem number 2, we want to calculate the integral of e to the 3x dx. So we can call 3x equals u and derivate both sides, so we have 3 dx equals u du, or dx equals 1 over 3 du. Now we go back to our integral and do the substitutions. E to the 3x equals e to the u, and dx equals 1 over 3 times du. Or our integral is 1 over 3 times the integral of e to the u du. And this integral is pretty easy, right? The integral of e to the u is e to the u. So this integral here equals 1/3 of e to the u plus our constant. Never forget the constant. Now we go back to our original integration and do the substitutions again. So e to the u equals e to the 3x. So this integral here is 1/3 of e to the 3x plus k. Now the last problem for today is problem number 3. We want to calculate the integral of x over 1 plus x squared dx. So the trick here, we just take what is complicated, in this case is 1 plus x squared, and call it u. Now we derivate both sides to find the x and the u. So the derivative of 1 plus x squared in respect to x is 2x, and of u in respect to u is 1. So we have that 2x dx equals du. Now, let's not isolate the dx or the x as I did before. Okay, let's use this as it is. If we go back to the original integral here, we have 1 plus x squared, this equals u, right? But we don't have 2x dx, we just have x dx. What we can do here, we can multiply it by 2 inside the integral, and also divide by 2, so we're not changing the equation, right? We're multiplying by 2 and dividing by 2. But we're leaving the half outside the integral and the 2 inside. So now we have 1 plus x squared, which is u, and also 2x dx, and this is du. So this integral here becomes half of the integral of 1 over u du. And this integral is pretty easy also. The integral of 1 over u du is the ln of u plus k, right? So our original integral equals half of ln of u plus k. And we know that u equals 1 plus x squared. So this integral equals half of ln of 1 plus x squared plus k. So that's it, guys. I hope you enjoyed and see you next time.
Hope you guys liked this video. To make your math geek happy, subscribe to our channel, and I'll see you later.